Okay, hello Year 9s and welcome back to Term 2. Now, what we're going to do in this first part of this term is we're going to go through a topic where we look through right angled triangles. So this first topic that we're actually doing is called right angled triangles. So right angled triangles. What we are doing in this topic is we're going to be looking at the relationships in a right angled triangle between the side length of right angled triangle. But then, so we're going to spend the first part of this topic looking at revising over and having a good look at Pythagoras' theorem again, which is something that you may have looked at in year 7 and 8. Then once we've done that, we're going to be looking at a topic, an area of mathematics called trigonometry. So trigonometry looks at the relationships between the angles within my right angled triangle and the side lengths of my right angled triangle. So that's what we're going to be doing in this topic at the start of this term. So what we're going to do first, we're going to revise over Pythagoras' theorem and go through what Pythagoras' theorem tells us. So, Pythagoras' theorem. Pythagoras' theorem deals with right angled triangles. So how do I know if a triangle is a right angled triangle? Well, for a right angled triangle needs a right angle. So what I'm going to do is I'm going to draw on a little square box there. It looks a little bit off, but that's okay. But what this square box tells me is that this angle over here is 90 degrees, or a right angle. So this angle over here is a right angle. Okay. Now what Pythagoras' theorem tells me is that there's a relationship between the three side lengths of my right angled triangle. I'm going to label them and give them names. So this first one over here, I'm going to call A. And this second one over here, this one at the bottom, I'm going to call B. Now A and B are my two shorter lengths. If you have a look at my triangle, I've got three sides, and A and B are going to be my two shorter lengths. Now, in your right angled triangle, it doesn't matter which one you call A and which one you call B. I could swap the two around. I could call this one A, and this one can be B. It doesn't really matter as long as the two shorter sides are called A and B. That's all I really worry about. The ones I do care about is the longest side. Now, the longest side in a right angled triangle, which is the slanted side, has a very special name, and there's another way that we can identify it. This side is called the hypotenuse. The hypotenuse is the longest side of a right angled triangle, but along with that, it is also the side that is opposite the right angle. So if you have a look, right angle. So if you have a look, if you look at your right angle and you look directly across it in your triangle, that side there is the longest, and it's also directly opposite, and we're going to label this as C. So A, B, and C. So here, all you need to worry about, the most important side to worry about, is your hypotenuse, the side which is opposite your right angle and is the longest side in your right angled triangle. Now Pythagoras' theorem tells me there's a relationship between the three sides of this triangle over here. There's a relationship between the three sides. And this is what it is. I'm going to scroll down so we can see it. Pythagoras' theorem tells me if I square the lengths of the two shorter sides. So if I find the square of the length of the two shorter sides and I add them together, that will actually get me the square of the longest side. So here, that's what I've written down over here. A squared plus B squared. So if I square the two shorter lengths and I add them together, that is going to be equal to the square of the longest side. Now just remember, when I square a number, so for example, if I'm going to write over the side here, A squared, that's just the same as doing A times A. Now there's a button in your calculator which can actually help you do this. It's the button that looks like X squared. And when you put that in your calculator, that'll just do the squaring function for you already. So for this topic, I recommend you get your scientific calculator wherever it's hiding, at the bottom of your bag or in the back of your bedroom. Go grab it, because we're going to definitely be using it for this topic. Now here I've actually written down Pythagoras' theorem in another way as well. What I've done, so this first way is what I've said before. If I square the length of the shorter sides A and B and I add them together, so that's what this bit is telling me. I square A and B, so I square A and B and I add them together. That will just give me the square of C. Now the other way I've written it is I've just swapped the two sides of my equation. I've just written it as c squared, so the length of my longest side, and if I square it, it's just going to give me the length of the two shorter sides squared and added together. That's all I've done here. I've also written an important note at the bottom that you need to be really careful with. You need to make sure that c is the length of your hypotenuse. Just make sure c is the length of your hypotenuse. So here, Pythagoras' theorem tells me that if I square the two lengths of the shorter sides, and I add them together, that's going to give me the square of the longer side.